Hello, in this video I'm going to be going through not the mid-course review, which is what it says on this piece of paper, the trial for the 2023 Engineering Studies HSC paper. Now this is an older paper. I updated it, and so there's going to be like a few typos, but I printed out 30 copies, so I wanted to try and make the most out of it. Okay, so we're not looking at the multiple choice, we're just going to go straight into the questions. Question 21A. We have a Flee question. So with Flee, what we have is Young's modulus, force, length, extension or change in length, and original area. Now, the Flee formula is not on the formula sheet. What we know is Young's modulus equals stress over strain. We've been given Flee. The great thing about Flee is you can rearrange it by replacing the vowels, or any of the vowels can be swapped. So if I want to find the extension, I just swap the E's. Now, so I've written my data. So here's a couple of things. I found a lot of people got this wrong, and they only got 2 marks. I just tell you the correct answer is 0.14 millimeters. A lot of people got that wrong. There were 2 tricks in this question. One is that the factor of safety is 11. So that means that the extension is going to be 1/11th of what it otherwise would be, about 9% of what it would be without that factor of safety. Also, the area is doubled, which halves the area. So, it halves the extension. So it's easy to double the area. Where I find most people have trouble is the factor of safety. So what I did is I did it without the factor of safety, and then I found the answer is 1.6. The reason I did it that way is so I could find out why so many people kept giving an answer of 1.6. And then I realized, oh, they didn't divide by 11. So I thought, okay, if I'm going to make something safer, is it going to stretch more or is it going to stretch less? It's going to stretch less. And so that's why the answer is 0.14. So anyone who gets the answer of 1.6 or someone who gets an answer of 0.24, they're going to get 2 marks. They've just made one mistake. If you can see that they've done anything with a formula where they've entered a number in here, they're probably going to get 1 mark, right? So if you've taken numbers and you've multiplied reasonable values, especially you've got to remember that the question A, the marking standard is lower for marking question A than it is for question D. So if you can see that a student has taken numbers off the page, multiplied them together in a way that seems sensible, they're getting 1 mark. You find that actually, funnily enough, that there's a lot of people who only get that 1 mark because there are also lots of people who just don't attempt it at all. Don't be those people. I urge you, even if I don't give you the 1 mark, right? Even if I don't give you the 1 mark, the HSC will give you 1 mark for multiplying some numbers together. Me, I want to see some meaningful numbers. I want to see them in the right spots. Otherwise, I'm not going to give you the mark. But that's why I do double checking. Okay, then we've got trusses. You haven't Year 11s haven't learned about trusses yet, but it is fair to say that trusses are a pretty big deal. Trusses are guaranteed to be in every trial that I ever write. Now, this was a typo, so I changed that on by the time we did our exam. But what we're finding is just reaction RC. Now, to find the reaction, what we need to do is we need to do moments to find we're going to do moments to find the horizontal component. So if we've got 10 kilonewtons and it's 1 meter away, just like, a first order lever, fat kids always win at seesaw, right? If we have a big force, we have a 10 kilo force here 1 meter away. If we have this only half the distance, to balance that out, this is 10 times 1. This is going to be half times 10 times 1 is 10. Half times what is 10? 20. So that's going to be 20. That gives us our horizontal component. The vertical component of C, if we've got 10 down, we're going to have 10 up. Only C can take the up. So it gives us 10 up, 20 down, and then we use Pythagoras' theorem to get 22.4. That was worth 2 marks. I adjusted that to make that worth 2 marks. You get 1 mark if you wrote 10. You get 1 mark if you wrote 20. You only get 2 marks if you write 22.4. I guess if someone did like Pythagoras and the calculator gave them 600, I would say, well, you should know better. You should realize that, yes, it's a hypotenuse, but it's got to be close to 20. It's got to be bigger than 20, but got to be close to 20. So 600 is obviously wrong, right? Okay, then we're doing the truss component. Now, the truss component, what I'm doing is I'm cutting the truss at this location, right? I'm cutting the truss at this location. I then am taking moments about C, right? I take moments about C. When I take moments about C, I then have two forces. I have the 10 and I have this force here. That's the 2 forces. By taking moments about C, I cancel out the moments. We'll learn more about this when we do trusses in greater detail. But as we cut through AB, so the two forces, this one and this one, they're ignored because we're taking moments about C. Then what we need to know is what is the perpendicular distance to this member AB? The perpendicular distance, when I measure it with a ruler, happens to be about 500. Otherwise, you can check out my YouTube videos where I demonstrate using trigonometry and I find the value, right? So that's the alternative way of doing this. Okay, moving on. Because it's we've got that same concept. We've got 10 times 1 versus half times 20. Now, we always assume that the force is pulling out. If we go about C, a force pulling out from here, from A towards B, they're both going to be going anti-clockwise. If they're both going anti-clockwise, it's not going to work. We need one going clockwise, one going anti-clockwise. So the force on AB has to be going in from A to B in order to be going clockwise, right? So if it's going into A, then it's no longer in tension, it's in compression. We'll learn more about that. Year 11 will learn more about that later. Okay, we're doing bending now. This is a harder question than it might have been, but I did help you by giving this formula. Now, a lot of students will memorize that. Otherwise, you have to use a bending moment diagram. I wanted to say to focus just on the fundamental concepts. The bending stress formula is given to you. Sigma B, or bending stress, is equal to mi over I. M is maximum bending moment, which can be calculated from this. Y, or Y bar, is the distance from the neutral axis to the extreme fiber, and I is the second moment of area which has been provided and will always be provided to you. If you plug in those values, if you plug in that the distance from the neutral axis to the extreme fiber is 50, we're going to use millimeters for everything. Why are we using millimeters? Because our assignment was given in millimeters. So we're using 50, the test gave us in millimeters. So we've got I is going to be this times 10 to the 6. Okay, so first of all, I had to rewrite mi over I, right? So I've written it as moment equals sigma stress times second moment of area divided by Y bar. I've plugged in those numbers. We know that if we use millimeters, we use megapascals. We go together like megapascals and millimeters squared. So we're using megapascals, millimeters to the power of 4, and millimeters. We plug in those numbers and that tells us our maximum bending moment equals 3.5. If you can see 3.5 kilonewton meters, you give that person 1 mark. Right, then what we're going to do is we're going to look at, they're going to have to manipulate the formula. I gave the formula that M equals FL on 4. Now, I've written 1,000 there, right, because I want to make sure that I'm working in the right units. I want to make sure that I'm working in newtons and millimeters. So what I've written here is I've said 4M over L equals F. So I'm rewriting that formula. Do you see how I've got 4 divided by 4? It's the same answer. How convenient that is. So that means that if they write 3.5 kilonewton meters, you'd get 2 marks for that. You have to do the third mark of writing force equals 3.5 kilonewtons, not meters, because the meters cancel out. Now, I saw at least one person who made a mistake that they wrote the L. L is the distance from the supports. I even wrote that here. The 4-meter beam, L equals 4. Right, so I really helped you out. If I was to include this question next year for the class of 2024, I would give them exactly the same question, just without that information. Right, I would expect them to have watched this video and to have known that they have to figure that out or draw a bending moment diagram, making it a little bit harder. Okay, moving on to a word question. Justify the use of carbon fiber reinforced polymers in the manufacture of bicycles. Well, we've got strength to weight ratio, aesthetics, corrosion. They're the 3 major reasons. Some people might talk about fatigue strength, and that's true, but it's not really relevant for bicycles, fatigue strength. But let's pretend it is. I probably would give a tick for fatigue strength. Me personally, I'm a fairly generous god. Question 22A, it's an A, so why not? Let's give them fatigue strength. But strength to weight ratio, anything that says, hey, strength to weight ratio, I'll give them a tick. Now, it does say justify. So if we were to cube this, justify means make a decision, giving criteria. I don't remember the exact wording. If I was smarter, I'd get that up. But so if you just write, so this student here, right, me, who just wrote STR to weight ratio, aesthetics, corrosion, I would give them 2 marks, right, because they've identified. They haven't written full sentences. If they said the strength to weight ratio means the bike can be more easily carried or means the bike will be faster, that's fine, you get a mark. If you say that carbon fiber can be made into a variety of shapes and a variety of colors, that's a mark. If they say it's corrosion resistant, which means it's going to have a longer service life, boom, that's 3 marks. Okay. Now we're going to move to compare two welding methods. This is a pretty easy question, right? Now compare means show how things are similar or different. It is more advanced than identify. Identify, so this student here has, when I say this student, I'm talking about me, I wrote these, but this student has identified 4 methods. I would give that student, because we're at B, I would give them 1 mark, right? If you identify 2, I'm going to give you 1 mark. If you then describe 1, I'll give you 2 marks. If you compare them, I'll give you 3 marks. So if you said stick can be done on site, but it requires more skill, whereas MIG is faster and easier, but can only be done in a workshop environment, I've compared them. I've said that where they're different. Really, the better answer would say they both still use electricity. I'm comparing is show how things are similar or different. If we're cubing, we're going to circle compare. We're going to box 2, right, to make sure that we remember that there's 2. We don't just compare 1 or 3. And we're going to underline welding, right, just to make sure that we don't do, wedding methods. Okay, so a lot of people talk about Oxy. Oxy doesn't use electricity, uses a flame torch. If you said stick and TIG both use 2 hands, you've compared them, right? You've said how they're different. But if you say TIG is better suited to, it can only be done in a workshop environment, that's 3 points. If they said that stick and TIG and you said TIG is better suited to aluminium and stainless steel, there you go, you've made a comparison. Yes? Is carbon welding a thing? I would write see me. Okay. So, as part of regular inspections, non-destructive tests are carried out on sections of aircraft frames. Sorry, I generally don't like to read out the whole thing. Okay, we want a surface test and an internal defect test. The 2 main tests I'm looking for, dye penetration and magnetic particle test. Okay, if you write dye penetration, what we do is we add a dye and then we do something to make the dye more visible, right? So if you said you use a catalyst, or the best word is if I say the word foam, boom, I'm giving that person a second tick, right? That's what I'm looking for. The idea is we put the dye on and then we have to do something to make the dye more visible. If you said magnetic particle test, so the idea is that the magnets are attracted to the surface defects, right? And someone who wrote something like fluorescent makes it more visible. Boy, am I excited with that. Okay, internal defects. Ultrasound versus X-ray. So ultrasound uses sound to see, ultrasound measures the distance that sound takes to be reflected to determine whether or not there's an internal defect. An X-ray shoots radiation, which, and we compare the amount of regeneration that goes to the other side, and that comparison allows us to detect defects. So that's what we're looking at for there. If there's something other than that, you leave it, you come and let me know, right? Okay, so this one here is pretty easy. Okay, so the best answer for the tires is vulcanized rubber, right? But if you wrote rubber, yeah, I'm not taking a mark off for that. Axle, toughness, strength. Now, generally we don't like strength, right? If you write the word strength, I'm going to make some snide comment that says, what kind of stress? Or I'm going to say, don't write this in the HSC. And at this point, we're getting pretty close to the HSC. But toughness, always acceptable. If you wrote hardness, well, hardness isn't really that important, right? We're not talking about wear resistance for an axle. What we're looking for is shear strength. That's the real important one, shear strength. If you wrote tensile strength, I'd pay that. Even if you wrote strength, to be honest, I probably, because there's so many, we're getting half a mark each. I'm not going to do quarter marks. Okay, yeah, I'd even give that. Okay, so light cover is going to be injection molding. Now, if you said something like blow molding or vacuum forming, I would actually give it. I as long as there's an answer. Yeah.
What about vacuum molding?
Yeah, I'll give that. I'll give you vacuum molding. Okay. Now, chassis. Chassis. The properties of the chassis we could talk about. So I just copied a student who wrote plasticity. Plasticity is fine, right? So the idea is it can be formed into a shape, right? If you said something like workability. If you said impact resistance, so hardness or toughness, scratch resistance, impact resistance, I would pay there. Strength is not as important on this one, funnily enough. But again, if someone wrote strength, I'd probably still pay it. Yep. Yeah, I'd give that. Yep. Corrosion resistance. So they took 2 bites of the cherry, but I'll give corrosion resistance. Fatigue resistance, look, I don't like it, but, I could be talked into a mark. Okay, now, plastic. So vacuum forming is a plastic method. Now, what some people may have got that mixed up with is pre-preg applications for CFRP. So if someone wrote carbon fiber or CFRP, I'd pay that as well. But for vacuum forming, we're looking at high density plastic, so HDPE, even PET. Now, I chose PET because that's plastic number 1, and it helped me to remember that. Look, if you went with ABS, I would not allow low density polyethylene (LDPE), but pretty well every other plastic. I wouldn't allow polystyrene, but pretty well every other plastic that we talk about. I wouldn't allow Kevlar or nylon. Oh no, actually, I would allow Kevlar or nylon. Yep. Look. So the thing is, we're giving half mark each, and so a half mark, half of a half is a quarter. That's going to round up, right? So you give it, you don't tick it, and then you give him the half mark. Yep. PVC. Yeah, PVC is fine. Yep. Okay. Look, I don't think PVC is used, but we can't rule it out. We can't say that it's not possible that this vehicle could be made with PVC. So, and there is definitely high density PVC. Electrical wire, the property is drawing. Some people write extrusion. It's the same thing. It's like it's half a mark. You got to use your judgment whether or not, if a quarter of a mark, whether or not that rounds up or down. Okay. Powder forming or sintering, covered in year 11 when we do brakes. The idea of sintering or powder forming is we shape it under pressure, and then it's sintered or it's heated, right? And what that does is that the crystals actually exchange atoms. Some people draw pictures. It's a good idea. I should also go back and say for that dye penetration test, some people drew pictures. Boy, that was a good idea, right? A picture worth 1,000 words. If you draw the gap, you draw the dye, then you show the foam expanding. It means, hey, I didn't know the words to use, but the teacher knows, this kid knows something. Okay, now what are the properties? What are the benefits? It gives a very high finish. No machining is required. It has porosity, which means it can be self-lubricated. It can allow different materials to be non-alloy. So, for instance, some materials can't be alloyed. If you need, say, tungsten and silver, silver has very good electrical conductivity. Tungsten has very good high temperature properties, but you can't alloy those materials. So instead, you can sinter them. They're pretty much the answers I'm looking for. If someone wrote cheap, I'd maybe think about whether or not are they the half mark, how that was going to work out. I don't really like cheap. What we want to see is, if you said there's low material waste, that's better than cheap. If you say that there's lower machine costs, that's better than cheap. If you said it's highly abundant material, right? So if you said steel is cheap, you shouldn't say steel is cheap. Instead, you should say steel is readily available and easy to manufacture, right? Yep. If they say the waste product is reusable, I'd pay it. Otherwise, I wouldn't. Go.
Easy replication.
Yeah, it's just over the line. Easy replication, yeah, just over the line. Yep.
Used for complex shapes and
Yeah, complex shapes is good. Yes, because no machining is required. Yes. Okay, moving on. Normalizing. Again, this is stuff you've done in year 11. Heat is heat to 900 degrees. If someone wrote heat to red hot, if someone wrote heat to fully austenite, if someone wrote to heat above the upper critical temperature or UCT, all of those are correct. Heat to 100% gamma steel, all of those are correct. Heat to 900 degrees is actually the more accurate. That's what Copeland says. Heat to 900 degrees C. Then cool in still air, then resulting crystal structure has less internal stresses, right? Which increases the toughness. Or if you said reduces the tensile strength, reduces the hardness. I just thought I'm going to accentuate the positive. I'm going to go with a positive rather than negative. Okay, so what are we giving in terms of marks? The drawings are worth 1 mark, right? The label is worth another mark. If they do drawings with no label, no marks. If you so what we want is elongated grains, small equiax grains. So that's 2 marks. You get 1 mark for heat, then cool and air. Heat plus air gives you 1 mark. Then the last mark is for either talking about the stresses or talking about the change in material properties. right? I think I'm being fairly generous there. I marked a question like this last year, and I think they were less generous than this. That was 3 marks, and you kind of had to have all going on. Okay. Question 24, A. So remember A's, we get a little bit more leniency for A's. We've got 3 marks. Remember, we're comparing. So for cube, we're talking about how things are similar or different. Okay, so compare the environmental impacts. So we box impacts, right? That means more than one of electrical vehicles compared to petrol cars. Okay, so EV cars use less petrol, right? They use less fuel of all description, right? They don't use petrol, but some countries, maybe their electricity is being generated from crude oil, right? Crude oil, a petroleum product. In Australia, our electricity is generated mostly from coal, right? In other countries, their electricity is generated mostly from natural gas, right? In Russia, it'd be natural gas. In some countries, right, like France, a lot of their electricity is produced by nuclear power. All of those things are non-renewable. There's a finite amount, and when we run out, there will be none left, right? So in 3 generations' time, they're going to say, I cannot believe that our grandparents set that stuff on fire to make heat, right? There were so many better options, and we set it on fire to make heat. Also, carbon dioxide is really bad, right? Carbon dioxide, it creates respiratory problems, which kill people, right? And it has been shown to have an impact on climate. So if you write reduce CO2 emissions and it can be run on renewables such as solar. Now, what it does not have no carbon dioxide emissions. It just reduces the carbon dioxide emission, and potentially, even if we run on solar, right, even if we use nuclear power, we still have a carbon dioxide emission, right? Even if you're running nuclear power, you still have to dig up the nuclear power, or you have to dig up the uranium. Even if you're using solar power, we still have carbon dioxide emissions that are attributed. Yeah. Carbon dioxide is attributed to solar power, right? In order to make the solar cells, there's some carbon dioxide that's attributed to that. But we can say it's a lot less when you have an EV, right? Also, it can be it's better suited to the use of renewables. It still has a negative impact in its production. So that's what I'm looking for 3 marks. You don't have to say all of those things, but what you need to say is you need to say that it reduces CO2, or it can be better suited to renewables, or it's more efficient than internal combustion engines, right? And you can say that it has an overall still negative impact, right? It's not value positive, right? We're not getting free energy, right? Okay, so that's what I'm looking for 3 marks. Another way of phrasing that it has a worse, if they say it is better, overall it has a better environmental impact than internal combustion, that's another way of saying it still has a negative impact. It's just better, right? By comparing. We're using comparative language. Okay, describe is features and properties, features and characteristics, right? So the features and characteristics of 4 things. Obviously here, this student has identified 5, right? 2 marks, right? Identify 5, you get 2 marks. Identify 4, you get 2 marks, right? To get the extra mark, there's half a mark for identify and the other half a mark is for the description. If you say, the radio telegraph allowed information to be traveled at high speeds, long distances, that's a mark. The AM radio allowed voice communication, one-way voice communication, allowed for entertainment, right? It allowed for radio plays. It allowed for music to be played to many people across long distances. It also allowed for emergency broadcasts. Every person who survived the Titanic survived because of Marconi's radio, right? Even Rose and who didn't share the door. Okay, telephone. I always feel as though I should say that, follow that up by saying Mythbusters says that, she couldn't have shared the door. But anyway, the telephone allowed for two-way communication, two-way voice communication, right? So you could also talk about CB radios or something like that, same concept. Voice over IP is using the internet. So if someone talked about Zoom, right? Zoom allowed for teleconferencing during the pandemic, right? That's a mark. Satellite phones allowed people to speak over long distances before the use of the internet. So when we're talking about things like talking internationally, it allowed for international communication. Yep, Did they describe them? Did they describe a feature? Did they say the radio telegraph sent Morse code using electrical pulses on a wire? They described it. They talked about characteristics and features, yeah? So that's a mark. Yes?
They talked about telephones and home telephones.
I don't think that's enough of a distinction.
Yeah.
Yep.
What about Bell's telephone?
Yeah, that is the telephone, right? If you then talk about telephone exchanges, right? So the telephone or the touch tone phone, yeah, that's a different concept, right? So Bell's telephone was an early telephone that allowed for two-way communication, voice communication, whereas the touch tone phone or the cordless phone, right? The touch tone phone, it did no longer require an operator, right? The cordless phone allowed people to make phone calls from any room in the house. Yes.
What about beams of light?
Right, see me and then I'll come back. Okay. Describe how engineers must behave ethically in the design of structures. I have written 4 different directions you can go with, right? Some of these overlap a little bit. Okay, first of all is material. Now, cube. Describe is draw. So circling the word describe, features and characteristics. Describe an example, underline or box. It was box example, right? You need to give an example, right? Most people did. That's fine. How engineers must behave ethically, underlining ethically, in the design of construction of structures. Design or construction of structures. I am really focusing on the word ethically. Now, it's an example. We're going to box the word an. If you write 3 things, right, this kid here who's identified 3 things, I'm giving them half a mark, maybe 1. Yeah? You're saying this answer should be 2?
No, I'm saying did he?
Okay. If they do 2, you pick the best one. Yeah? If they do two, you choose the best one. Yeah? Okay. So material, this is why I said cube 3 times, right? To try and reinforce this idea of cubing. Material procurement, right? This is when you buy stuff. If you go and buy stuff from your cousin Jimmy and Jimmy says, hey, the government's paying for this. I know this copper wire only costs, $10 a meter. How about I sell it to you for $20 a meter and we split the extra $5? Like the $5, we get extra $5 each, right? So let's rip off the government, right? That's called, that's called fraud is what that is. But, in order to prevent this, we have something called probity, where we don't just get one price. You have to have 3 prices, and you have to state if you have a conflict of interest, right? As school teachers, if we buy something from school, we have to say if we're buying goods or services from someone we have a prior relationship with, right? Land purchase. So land purchase, if you buy the land, so for instance, the TV show Boardwalk Empire, right? He commits fraud by buying land that he knows, that he pays government officials to build a highway on, right? Because he knows that the highway is going to be built on this land, because he pays them to choose his land to buy, he knows the land is going to drastically increase in value, right? So that's, again, another example of fraud, right? If you choose the land that you're going to buy because you have and this is where, New South Wales premiers multiple New South Wales premiers have got in trouble for this. Structural design, Rio cost cutting. So if you, that was my very short answer, but let's say if you design, engineers can be pressured into using less materials than they're required under the Australian standard in order to save money for the developer, right? Doing this is a breach of ethics, right? And you could be sued for criminal negligence in this case, right? In worst case scenario, I have worked for a company that got sued for this, right? And, it cost them a lot of money. Like, we're talking millions. If there's deaths, you could go to jail, right? If they find that you not just made a mistake, but you actually committed fraud, right? If they can find say an email where you were pressured into reducing the amount of steel used in a bridge and people die, you will go to jail, right? If they can prove that you willingly and knowingly committed fraud, you will go to jail. It doesn't happen, right? I got to say, if you look up the actual cases of engineers going to jail, it's very rare. And that's because, by and large, engineers are scaredy cats, right? Engineers are very risk averse. It's a good thing, right? We're worried about getting sued. But often businesses will say, come on, do we need to be quite so risk averse? And you say, yeah, because we've got a Australian standard that requires us to meet a standard. Okay. Inspection conflicts of interest. That's just conflict of influence. It should say conflict of interests. So you build a building and you hire your best mate to go and check it and say that it's okay, right? This happens all the time, right? In Australia, it used to be that you had to hire the council, right? The council would come out and check it. Now, private individuals are allowed, and they show up. And so my mate shows up and he says, hey, look, this doesn't meet the standard. And you say, hey, I'm building another one of these next week. Do you want to inspect that, or do I get someone else who will, who'll play ball? And you're like, okay, I guess I'll sign it off. If you do that, right, that's fraud, right? It's criminal negligence, and it could be jail time. This is also why a lot of people say don't buy anything built after 2000, right? Because the standards change. I would say if something's been standing for 10, 15 years and it looks like it's okay, probably okay. But there was a huge difference and lots and lots of court cases came from buildings collapsing because of conflict of interest. Yes, go.
They talked about the noise that would be made by the constructing.
Okay. I could consider that, yeah, not taking into account community interests. If they wrote a good answer, I can see that it could be an answer option for 3. Yeah, so you've got to consider all stakeholders. So a design that disadvantages the public could be an ethical consideration. Yep. Go.
They just list that they have to determine a good location for a cell tower so that it doesn't hurt public health, put anyone at risk.
Well, it's a similar thing, but that's only an identifier. I'll give them 1 for an identifier. I'll be generous on a 3-mark question. Okay. Calculate the mechanical advantage and velocity ratio of the mechanism. I just did this with my year 11s. So mechanical advantage is load over effort. The effort is always the pedal, right? The effort is the engine or the human, right? So the effort going in is 450. The load is 70. So I take load over effort, 70 over 450 gives me this number, right? About 1/6. And then I have the velocity ratio. The velocity ratio is we're taking the diameter from where the force is being applied. Now you've got to remember that just because this wheel here, actually the thing that's moving is the gear, right? The whole gear. So it's 170 times 2, totaling times pi, but the pi's cancel out. The wheel is 700. Then we multiply it by the velocity ratio, the velocity ratio of the gears, also known as NREV. And so what we have is driven over driver. The driven wheel is 20, the driver is 50. That should give me an answer. It's close to 1/5. So 1/4 over 1/5 gives me an answer of 80%. Yeah, 8 over 10, 4 over 5, 8 over 10, using 1/5. So that's the efficiency. You can't have an efficiency greater than 1. Go.
He said 80.1%.
Yeah, anything close to 80. Yeah, within a couple of percent, because that's where the rounding matters. Yep. That's fine. Anything 1.5 and 1.9 are sufficient. Yep. Like we're not taking marks off. If someone wrote 0.2, I'd maybe shake my head. I'd still give them a mark though. Go.
They got 83%, but the mechanical advantage of the velocity ratio is incorrect.
If it's totally incorrect and they got 80%, 1 mark. Yeah. Yeah. Because effectively we're giving a mark for mechanical advantage, a mark for velocity ratio, a mark for efficiency. It's pretty simple. Okay. If you can see that if they just pick the answer mechanical advantage 2, velocity ratio 3, yeah, I still am going to give them 1 mark if they wrote 66% for that. Yeah, I would say that their efficiency was correct. It was correct based on the working out they did. Okay, question 25B, we're talking about power. Now, power equals force times velocity. This used to not be on the formula sheet. I've got a good mnemonic about Flavor Flav and how he fights the power FV. Now, the thing we have to remember is we have to remember to change our velocity into meters per second. So 10, now you get 1 mark for doing that. Right, 1 mark for doing that. You get another mark if you just did force equals 300 divided by 10. Right, if they wrote 30, you give them 1 mark as well because they made a mistake, but they get 1 mark. The correct answer, 2 marks, is 108. I got to say, a lot of kids got that right. I found that most of anyone see that they didn't get it right? Okay, but still pretty good percentage. Oh, okay, maybe yeah. Okay, go.
What question was it?
Yep.
He did 108,000.
108,000 is correct answer. I've written K. Do you see I've written K? 108,000. Yeah. Or I've written 108 times 10 to the 3. Yeah. I just wrote a K because I was lazy. I'm doing this really fast. I did this about 40 minutes, right? So you have 2.5 hours to do this part of the paper. But I wrote it. So, I know what the questions are going to be. Okay. So here we're doing friction. Now friction, I like to use the famous too many guys formula. My friend Disco, he went on in Lyon, the best nightclubs were on boats. He went on a boat and there were too many guys. He hit his head on the sign, having a bad time, and then he got sneezed on, mu cos, right? I'm going to expand that out and I get this. This is a more accurate, this is the HSC will give us answers that look more like this. Mg sine theta plus or minus mu mg cos theta. Now, I've underlined the word move up, right? If you're moving up, the friction is going to be bigger than if the thing is just sliding down. Friction helps you and you need less force to hold a boat if it's sliding, if you're just trying to stop it from sliding. But once you need to pull that boat up the hill, now friction's like, no, I want to stay right here. Yeah, so you need more force. Plug in the numbers. Pretty much, if someone writes some sort of too many guys, I'm going to give a mark for that. Any version of too many guys, they get a mark. And then if they plug in the correct answer, they get a mark. Okay. So what have we got here? We've got a 2-ton vehicle, stationary on a 40-degree slope, 20 meters long. Now, I saw some people write 20 meters down there. And I'm like, oh, I don't like that. I'm going to mark those people as wrong. And then they can come and argue that I just misinterpreted the question, right? So if they do tan, right? So some people, if you see a tan, give them 1 mark. But if they come back and argue it with me, I'll give them the mark when they come and argue it, right? Because what we should be using is cos. Sorry, did I say wrote sine? We've got opposite and horizontal. Opposite and horizontal. So, yeah, okay, that's right. I'm not very good at trigonometry. I just get away with a Disco number. It does a lot of work for me. Otherwise, I have to think about it. Okay, the mass does not matter, right? The 2-ton does not matter. See how the mass cancels out? So we've got the potential energy and the kinetic energy. They're going to be equal, and we just rearrange that formula. So if you see something like this, if you see v squared equals 2gh, that's a mark. Straight away, if you see v squared equals 2gh or v equals the square root of 2gh, they're getting a mark. Okay. This drawing. This drawing, I'd say, is harder than what I would expect to see in the HSC. Except, I think it's okay to give it to you as a trial. Why do I think it's okay to give people as a trial? Because it's a past HSC question. And more to the point, this guy, wait, that's a Black Keys song. This guy, he has done a video talking at great length about how to draw this ridiculous drawing, right? I even gave this to my year 10s last year, right? So that's the correct answer. That is the correct answer, right? How do I know it's the correct answer? Because I looked at the answers. How to get the answers. This is from the 2005 paper. You have to get a book, right? You have to buy a book that someone has of the answers for the pre-2008. If someone lets me know, I have a copy of that book, right? So I looked at the answer. Now, remember I did this whole thing in about 40 minutes. I made a mistake when I did it. So if we look at my answer, I didn't do my that correctly. There should be 2 lines there for the thread, and I think it should be a little bit longer, right? But that's a minor error. You are allowed to get full marks, even 6 marks with a minor error. They are not expecting it to be perfect. They understand that you're doing this under exam conditions. Now, when I first started marking, my mentor told me that if you don't see a difference between light and dark lines, I'm not giving you a mark. I don't think that's as true as it used to be. Why? Because of scanning. The HSC is now marked with scanning. That said, I get the chance, if I can't see while I'm marking your papers, right, I can see the difference between light and dark lines. If I don't see light and dark lines, I'm going to dock you a mark, right? I'm looking for 6 things. I want to see the hex nut. If the hex nut looks right, like this, I'm going to give you a mark. If I see some attempt at a thread, I'm going to give you a mark. If I can see a difference, that your lines need to look different. So this line needs to look, your sectioning needs to look different to that, which needs to look different to that. If you can see those 3, that's a mark. If I can see this object here, that's a mark. If I can see, you lose a mark for having a hole here. There should not be a hole here. some people have drawn holes there, and that's not a deduction. I need to see 2 lines here. If you see that, add those together, and that gives you a mark. Now, I'm happy to compare those. You know, there's some marked ones out there, and some you can compare. No, I'll look at them later. Okay. Now, we move on to the next one. The next one is true length, right? Ultimately, what am I looking for? This is 4 marks. It's a 4-mark HSC question. I have not done the answers for this. I have not done this one before. But what are we looking for? They're saying, show some understanding of how to draw this thing. Gets you 1 mark. Partially correct gets 2 marks. A correct thing gets 3 marks. Now, I don't care about the actual numbers. If it looks like this, I'm giving them the mark, right? So if it goes close to the edge of the page, I can see these need to be perpendicular. So if these corners are perpendicular, right angles. Now, this line and this line should be parallel. This line and this line should be parallel. If I see that, if I can see this shape, this trapezium, right? If I give that 2 marks straight away. If I see this line, those 2 lines, or these 2 lines parallel, I'll give 3 marks. If you see some horrible mess, but you can see that a compass has been used, that's a mark, right? A horrible mess, but there's a compass that's been used, they get a mark. If you can see 1 mark, probably, right? If you can see 1 line has been drawn perpendicular, 1 mark. Can you see compass marks? 2 marks. Okay. So, okay, now we're going to talk about how wings generate lift. My year 10s know this because we did it in year 9 and 10. Okay, how does a wing generate lift? Air goes over the top of the wing faster than below the wing, which means it has lower pressure than below the wing. This generates lift. Right? Now, technically, I've made a mistake here. The lift is actually perpendicular, which is hard for me to draw a perpendicular arrow on this thing, right? Should look like that. Yeah, that is actually lift. I've drawn this up arrow. In actual fact, the lift is generated perpendicular to the wing. Nevertheless, now, let's assume this student has literally just written fast, low pressure, slow, high pressure, and they've drawn the wing, the air going around the wing. I'd give that student 2 out of 3. Right? They've done a diagram, they've labeled the diagram, 2 marks. If they said something like Bernoulli's principle, right, that gives them the fast or the low pressure part. If they say fast plus low pressure, or if they say low pressure plus Bernoulli, right, any combination of those 3, I'm going to give them 2 marks. The diagram gives them 3 marks, yeah? If you got any questions, let me know. Later, that's what I mean. Okay, now this part here is lots of fun, right? I have drawn deliberately drawn the crappiest engine I can. The engine is a tube. Effectively, it's a tube, right? At the front is a compressor. At the back is a turbine. In the middle is some sort of idea of ignition, right? I am looking for suck, squeeze, bang. What about how I just love this highlighter now? My whole life, I just needed a highlight. Suck, squeeze, bang, blow. Now, if you write suck, squeeze, bang, blow, I'll give you 1 mark reluctantly. If you say instead, the air is compressed or drawn in and compressed, right? The intake, yeah. So intake is drawn in, compressed is squeezed, bang is anything that talks about the ignition or combustion process, right? Or the power is generated from burning the fuel, right? And then it is exhausted faster. So you need to say that the air entering goes out faster because that's how we generate thrust, right? This process accelerates the air, and by accelerating the air, Newton's 3rd law says that if it goes fast out of the air, out of the engine, means the engine is going to move forward fast. Yep.
And you talked about exhaust and
okay. If you label suck, squeeze, bang, blow, which I don't really like, but hey, I would rather students write suck, squeeze, bang, blow than nothing, right? That is an improvement on nothing.
That was suck and blow.
Yeah. But if they say compression, right, the air is compressed and it is exhausted at higher speed, I give 2 marks. A good diagram, right? A good diagram that, yeah, I'd probably look at maybe giving 3. But remember, my rule is mark hard and make them come to me, right? My rule is mark hard and make them come to me for the 3rd mark. Yeah, if in doubt, mark low. Yeah, yep. Okay. Why do planes have low factor of safety? Right? Low factor of safety is bad. Elevators have really high factors of safety, and they're incredibly safe. Elevators are the safest form of transport, right? By far. The only people who get killed in elevators are elevator technicians, and that's very, very rare. Elevators are incredibly safe. Yes, it's frustrating when you get stuck in them, but they're incredibly safe, right? Now, low factor of safety because it needs to be light. Why does it need to be light? To save fuel, or because it's better for the environment? Saving fuel means it saves money, or it's better for the environment, right? We compensate this with regular maintenance and inspection. I use this question all the time, right? And I think this question was relative. I marked half the papers, and that was answered. The aeronautical stuff I found was answered really well. I was really surprised at how I'm astonished. I actually was bragging to the other teachers in my staff room about how my students have answered this section really well. Yep.
So he talked about how because there's more parts, there's more room for error.
No, that's not right. If you said there's much greater control, right? There's much greater control of the parts. The parts have to follow like a chain of custody. They have to be signed off. That I give you a mark for. Yep.
Have we maintained the well designed so minimal chances of risks occur?
1 mark.
I think he's kind of done similar.
Yeah. Okay, so yeah.
Executive safety feature.
No, I don't know what that means. That person can come and see me. Okay, now here I've got a plane. The angle of attack is 19 degrees. That means if this is 19 degrees, this is also 19 degrees. That's just how geometry works. You have to trust me on that one. Now, if I have a triangle, weight is always down. It is the definition of down. The way that things fall when you drop them is down, right? It's also the definition of vertical, right? So I always start with a vertical line down. I start with that. That's the weight. The lift is perpendicular to the wing, as we discussed earlier. The lift is always perpendicular to the wing. And then what's left is the thrust minus the drag. Yeah, the thrust minus the drag. They didn't ask anything about thrust minus drag. That's why this is only worth 2 marks. Easy question, right? If I know that the weight is 800, well, the lift is going to have to be smaller than the hypotenuse, but it's going to be close. If someone just drew this and they wrote 700, I'd give them a mark for that, right? If someone drew this, drew this diagram and they wrote 800, 700, I'd give them a mark, right? Because they're like, it has to be close, it has to be less. Yeah? Okay. AM radio changes the amplitude. Yeah. Phase modulation changes the direction. Yeah, changes direction. Changes direction, right? Let's see the changes. There's a change in direction, change in direction, change in direction, change in direction. So I've got 4 changes of direction. FM, where the value is high, right? Where the value is high, we have a tighter line. Oh wait, that's the wrong one. That's why that doesn't look right. See how the lines are closer together? Yeah, where the value is high, the frequency changes. Oh, I can't see. Oh, no. Yeah, cross it out. Make them come to me. Okay. Emergency radio has to be AM. Why? Because emergency radio goes along, AM goes further. Okay. An AND gate should have 2 open switches in series. Yeah? If they drew transistors, I give that. Right? They don't actually have to have a power source, but they should. Yep. Nope. Nope. No. I said draw a circuit representing an AND gate. Okay. Now, this is what the sound actually sounded like. I don't need that. I only asked for demodulation. That's what the sound actually looked like. Then, the radio converted into this shape. The diode got rid of the bottom half. The capacitor smoothed out those lines to look like this. Yeah? The diode removed the bottom. The capacitor smoothed out the top. Now, if they drew this shows the diode, it shows the capacitor. They have to use their words to describe that the diode removes half, or it only allows the flow of electricity in one direction. And then the capacitor smooths out the output. Yep. Okay. They need to have a diagram. The diagram needs to be labeled, right? They need to say the diode only allows the flow of electricity in one direction. This diagram shows that. The capacitor smooths out. This shows that. Okay. That's it. That's the end of the paper.